Okay, so I'm going to take a little time to talk about describing the image now. So before we were talking about how the image is formed, and now we're talking about how to improve the image. So first of all, we need two words to help us describe images. And I think these are fairly everyday words. However, our understanding of them has to be very, very specific. So in relation to an image, we have these two words, sharpness and contrast. So we need to know those definitions. So first of all, sharpness, you can write this down as directly as how well the edges of the structure are defined. So do they look soft and furry and a little bit sort of grey towards the edges, or are they very, very clear lines, very, very sort of black and white? It's very sharp and clear where those lines are. Contrast. This is to do with the darkness of the image, really. It's the difference between the blackening of the structures, so the difference in degree of blackening between the structures. So looking at some images here, the contrast on this image is not as much because we can see that soft flesh in there as well. If we were looking at the bones, the contrast perhaps isn't really high enough because we can see those other things. Maybe slightly softer X-rays, I would think. Whereas the edges of these ones are a little bit more clearly defined. So the contrast on this image is clear because this is very white and this is very dark. In terms of sharpness, I'd say this is slightly softer on the edges here. I would say this is a sharper image, and say this one over here where I can see very clear lines. Okay, this one is in negative, by the way, so that's slightly different. You might take a moment to look at them closely and see if you can figure out where they're from or what's odd about them. So contrast, very clear black and white. Sharpness is very, very straight, or very, very stiff in edges. They're not soft at all. Over on these bones here, they're slightly softer. Maybe that is probably because the contrast is not as high as it could be. So that's describing the images. And then another thing that we can improve about images, since we are still here, is we know that they are slightly dangerous. If possible, we would like to minimise the amount of exposure to the patient, and one way that we can do that is to form the image very, very quickly. So we can improve not the quality of the image, but the likelihood of there being any difficulty with illness from lots of X-rays by producing them very, very quickly. And we can do that by increasing the intensity, by having more photons, a higher cathode potential difference, to produce the images with more energy in a short amount of time, so we can produce the image very, very quickly. So that's the other thing we can do to improve the image. I'm going to take a little time in a moment to explain how sharpness can be improved by using a picture. So we'll do that, and I'll also briefly talk about how that can be improved as well, and what they do in the machine to actually produce a sharper image in the first place. Okay, so I'm going to take a little time to talk about sharpness and how the X-ray machine improves sharpness. So first of all, we just want to remind ourselves that when you've got rays coming out of a gap like this, even very, very high frequency ones, we eventually get spreading of the rays as the distance goes on, like this. So as it comes through the window, it's spreading out. I'm exaggerating it a little bit. It's getting wider, like that. Okay, that always happens. Okay, so one thing that we can do first of all to avoid that being quite as much is to make that hole smaller. Okay, so if the hole is smaller, then the ray is going to be thinner. Now we'll talk about why that's important in a moment. But let's imagine for a moment that we are X-raying something really, really boring. I'm keeping something like a similar size because I want to compare two things. So I'm going to draw around this board rubber, like this, just roughly. Remember, it's a shadow image, okay? So, if I have my screen over here somewhere, you have to look at how that image is formed. Now, if I get a ruler, the shadow is where the light itself is blocked a bit, isn't it? So, it can go there and there to produce that image. And we can see that image has actually got quite big by the time I've got to the screen. And that's one thing that we should notice. But we shouldn't forget that the light rays actually don't just go to the edges like that. The worst case scenario is one comes from this side, okay? And then the same on the other side like this. So what this area here is, it's known as a penumbra, okay? This area here, if this were light and a shadow we were talking about, this would be very dark because it's completely covered. But this area is like the furry bits on the sides, okay? So if I want a sharp image, I want these furry bits to be as small as I can possibly get them. And there's a couple of ways that I can deal with that. The best one though is to have a big distance between the object and where the rays are coming from. But I also want those rays to be as tight and as thin as possible. So just to show you what a difference that it can make, I'm going to redraw it now with the board rubber a lot further away. Okay, so let me draw that for you now. Let's have it here. Now when I draw my rays, I have this. I'm not drawing that very central, unfortunately, but I think the idea will still come across. So that's the main part of the shadow. Now when I do the penumbra from the other edge, like this. We can see this area here now is a lot smaller. The furry bits around the edges are a lot less, and that means that the penumbra is smaller, the edges are sharper. Now the other thing I can do is to stop the beam from spreading as much. And I can do that through collimating, so it won't get the chance to spread as much. So here is where the window is, but then I have another thing here to stop it from spreading any further, and then another one before my board rubber. So this is the normal window, then I have my ray coming out like this, but it's stopped here from getting any wider. Through here it starts again. And then again, that allows me to have a big distance between what I'm X-raying and the object, and I get a small penumbra, even more so. So this is my receptor. Now when I have my board rubber, it will be less. So that's collimating the beam. That's done with lead shielding, and that will also improve the sharpness of the image. Okay, I just wanted to spend a little time just looking at the kind of images that hard and softer X-rays are useful for. So this would be produced by quite hard X-rays because it's only the bone really showing, whereas this one has the hardness a lot softer because it's dealing with soft tissue. It needs to be absorbed by these softer tissues, whereas they would normally pass through with harder ones here. So this is, sometimes it's suitable to have softer X-rays, so it's the soft tissue that is doing the the absorbing. So that's a softer, produced by softer rays, and this one would be harder ones. As a rule though, that would be that the majority, this area here, the majority of our X-rays would be in that softer area. But as a rule, I'm not really interested in any of this stuff here. I don't want any of that because it's probably being absorbed by the body, and it's not producing the image at all, so it's only doing harm. So it is necessary to try and filter those out, and that is done with an aluminium an aluminium grid, that it stops the scattering, it stops the sort of photons, and it stops the or it filters out the softer, longer wavelength, lower frequency rays that are not really doing anything that is useful, even on the kidney one. When the kidney one is produced, it's probably got the anode voltage adjusted so that the majority is right here, and it's exactly as they want it, but there will always be a range somewhere near the end here of longer wavelength ones, which we don't want. They are doing harm to the patient, if anything. So they filter them out with these aluminium grids, this aluminium filter. Okay, so that's improving the experience for the patient.